Okay, so this is going to be the first example with LOW-PEE-TAHL rule or the hospital rule. So first I want to make sure, and this is important, I want to emphasize this, whether you do it in your head or not, make sure you get 0 over 0 before you apply LOW-PEE-TAHL's rule. LOW-PEE-TAHL's rule says take the derivative of the top and the bottom and then plug in. So first I'm going to do 1 to the 5th, which is 1. Take away 3 plus 2. That's negative 2 plus 2, that's 0. 2 times 1 is 2. 2 minus 2, 0. So I know I'm good. I'm safe. Now I can use the rule. I have this. This is a limit of indeterminate form. It is 0 over 0. So LOW-PEE-TAHL's rule says take the derivative of the top dude, which is 5x4, right? Multiplied by the power of subtracting them. The derivative of anything times x is whatever's in front of it. The derivative of 2 is a constant, so it's 0. Derivative of 2x is 2. Derivative of that is 0. How? This is LOW-PEE-TAHL, right? There's LOW-PEE-TAHL. Derivative top, derivative bottom. Not quotient rule. You just take derivative, derivative. Now I'm going to plug in again. Plug in 1. There's no x on the bottom to plug in. 1 to the 4th is 1. So you end up with 5 minus 3 on top, which is 2. And you have 2 on the bottom. So that limit is 1. Now, if you didn't believe that this was true, you could pick a number really close to 1, like say 0.99, and on like a calculator or graphing calculator, put 0.99 here, 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 and compute it, and you're going to get 1. So it works. All right, this is the second LOW-PEE-TAHL example. So you have limit as x goes to pi over 4. So remember, pi is 180. So pi over 4 is 45 degrees. So first I want to I got to make sure. I have sine 4x, so I'm going to put pi over 4 there. Now the 4's will cross out, so I'm doing sine of pi. The sine of 180 degrees, if you look on the chart in the trig, I have that trig formula sheet. This is 0. So I do get 0 on top. Now on the bottom, whoops, I have cosine 2x, but x is going to go to pi over 4. So now this time you put the 2 into the 4 and you get pi over 2. Pi over 2 is 90 degrees. 90 degrees is up over here. Cosine of 90 is 0 though. So you get 0 on top, 0 on the bottom. So you do get indeterminate form. So this is 0 over 0. So I am allowed now to use LOW-PEE-TAHL's rule. Now, these are chain rules. So you have to be very careful when you take your derivatives. You have to watch your signs. And you have to remember, sine u. So the derivative of sine 4x is cosine 4x times du, times 4. Now the derivative of cosine 2x is negative sine 2x, right? Cosine u, it's negative sine u du, so times 2, right? This is the du. This is chain rule. Now you're going to plug in again, and this time keep your fingers crossed. So now you're going to have 4 cosine 4 pi over 4. Wherever you see x, put pi over 4. And just relax. You have your list of values, so you shouldn't be freaking out. Same as before. Those 4's cross out. You get 4 cosine pi on top. On the bottom, whoops, don't. This was me. This is called anticipation. It was pi over 4. This 2 is going to eat up the 4 and make a 2, which I screwed up and wrote the wrong thing initially. I was anticipating this. So you replace the x's with pi over 4. Don't be a dumbass like me and put pi over 2 there, because then you cross out the 2's and get a 0 on the bottom. So cosine pi, if you look on your table, it's -1. The sine of 90 degrees is 1. I mean, these have values. These are defined. They're not 0. So I got lucky. This is going to work. On top, I get -4. On the bottom, I get -2. So altogether, when you divide it, negative over a negative is positive. 4 over 2 is 2. So that limit is 2. Even though it's 0 over 0, when I plug in directly, this limit is defined. It comes out to be 2. So third example of LOW-PEE-TAHL. This time we have E. And again, I want to just make sure, you can do this on the side, or you can do this in your head. I'm going to plug in 0 for X up there. Now, 2 times 0 is 0. Anything to the 0 power is 1. E to the 0 is 1. So I get 0 upstairs. Obviously, 8 times 0 is 0 on the bottom. So this is indeterminate form. So I'm going to do my LOW-PEE-TAHL rule. I always write this to indicate that I'm doing the rule. So lim x goes to 0. Make sure you write this there. You don't want me writing it for you. There's a penalty for that. The derivative of the top. The derivative of 1 is 0. So you got to be very careful here. The derivative of e, now remember, there's a minus there. So let's put it so we don't forget. The derivative of e to the u is e to the u. So I have e2x, so I write e2x. Then I take the derivative of the 2x and I throw it in the front. The derivative of 2x is 2. The derivative of 8x is 8. Easy peasy, man. Take that 0. There's only one place there's an x now. So put it up there in the power. 8 stays. This is it. Derivative plug in. Derivative top, derivative bottom, plug in. E to the 0 is 1. Negative 2 times 1 is negative 2. Now, don't leave it like that. I'm going to be unhappy if you leave it as 2 over 8. I'm going to be more unhappy if you tell me that this is negative 4. So be careful. Don't space out and do anything strange. So that limit, using LOW-PEE-TAHL's rule, negative 1 over 4.